What is this, Lady Ada?
Hey everybody, and welcome to the show and tell. Wow, it's amazing. So many years we've been doing show and tell, and yet we're still doing it. It's me, Lady Ada, with me, Mr. Lady Ada, here at the Adafruit factory. We've got a payphone, we've got puppets, we've got machines, we've got all these people coming by and visiting. It's going to be amazing because I'm Adafruit folks, and some people who we just like hanging out with us, show and telling what they're doing. So we're going to call people, and then we're going to hit some 50. So mute your mics, and let's start off with known Pedro.
Hello, everybody. Hey, guys. So this week we're releasing the Thunder Helm from Legend of Zelda Breath of the Wild. So last week I showed off what it looked like when I was just prototyping it, and we're just using the translucent material here because we have a bunch of that. But here's what it looks like completed. We're using the gold PLA, we're using some translucent blue and red for the gems. And the thing I'm really proud about is the headdress on the back, that we're able to actually have it on that, because in the game it's just sort of just floating in the back. So it's attached to an elastic band. I just gutted one of the costume goggles that we have in this shop. So I'm just using that for that. And
Hey, put it on. Wow.
Visibility is low.
Amazing.
Pretty low, but
Yeah,
it's pretty cool. It
you
definitely
can see under here. How many fingers
you
are
could,
on that?
2. So you could at least see, so you don't like run into a wall, but definitely completes your cosplay if you build up the Guardian shield and the sword that we built in the past. And of course,
You need a horse to ride on. That way you don't have to know where you're looking. The horse will just take you.
Exactly, yeah. So really proud of this design because it's all parametric. So it's all sketch-driven design inside of Fusion 360. So you can actually adjust all the curvatures for the contour to your face or the size if you want to split it up to a smaller printer size. And everything is held together with M2 screws. So you could take this all apart if you're traveling for a cosplay or whatever event. And should fit nicely into a suitcase. And what are the other things?
Check out the guide. We have a learning guide. We have a nice video to go
full
with.
Step by step. Lots of good tips during 3D Hangouts earlier today on how to actually get a large print to complete without failing. A bunch of like the design techniques that we use to actually get everything done. And that's pretty much it.
Sweet. All right. Thanks for the update. Okay. Next up, JP.
Hey, everybody.
Hello.
Hello. So I'm going to show a little tease of a project that I'm going to be publishing a guide on in the next day or two. This is the chessboard puzzle remote actuator. So it unlocks a linear actuator for a secondary puzzle within an escape room type of environment. And let me try to switch cameras to the one that's pointed at it so you can see a little better what I'm talking about here. So here we go. This is the chessboard. So this has the RFID reader inside of it, as well as a RFM69 Feather M0 to transmit to another reader that's inside of this one, and this one has a linear actuator and a motor driver. So the way the puzzle would work in an escape room, you'd get people to get some pieces, probably a lot of them, and then have a clue that leads them to setting a couple specific pieces on a couple specific places. So right now I have it set up for G3 and H3, and when these two pieces go, then the linear actuator opens the drawer up, and then we have other artifacts that would be part of a different puzzle. Also, for the person running the thing, I'm using one of these little NFC RFID rings that has 2 tags in it. So again, I use a combo of 2 tags to reset it, and then it locks it and preps it for the next victim. I'll give you a little peek inside here, and then you can tune in tomorrow for a more in-depth view. This is a little bottom I made inside of this folding chessboard so that we had some space to put the guts of it. So you can see little guts there. There's our RFID reader on a little proto board, or there's our RFID reader, there's our feather with a little proto board there, antenna, and battery. So that is my next crazy mystery box creation.
Wow.
Okay.
Amazing. Tune in tomorrow for more details.
Yes. See you
The
then.
mystery will be mysteried.
Yeah, it should be, what time? 12:30 Pacific and 3:30 Eastern Standard Time. So tune in.
All right. Next up, Tony D.
Hey, yeah, sorry, not in the usual spot. I have some work done in the other room. But anyways, I just wanted to show off real fast. This is an altimeter that I built using the BME 280 barometric pressure sensor, and a Feather M0 Express. It's running Arduino code right now, but I'm going to make it run CircuitPython code. And it's kind of cool. It shows the altitude that you're at and the pressure, and then you can press a button and it will switch to the temperature and humidity display. So it's using a little OLED from the Featherwing. Really handy. And then I've compared it with an altimeter watch. So of course I have to test it. So I took it up to 10,000 feet on Mount Rainier over the weekend. And my altimeter was saying 9,900 feet. And this thing was saying 9,800 feet. So it was pretty close. And you have to calibrate it with sea level pressure and things, which change every day. So I'm going to call that a success, that it's a pretty nice sensor. So look forward to that. I'll probably do more with it in the future.
Okay, cool. Thanks, Tony. All right, last up, Scott.
Hello. Couple quick updates. One, we just passed 200 people online on Discord, which is super cool.
Yay!
We broke 900 registrations total.
That was fast.
Super fast. It's awesome. So if you're not on Discord, you should join. It's a blast chatting with people all
Saturday,
week.
we're going to give away a ton of trinkets in the chat room.
It's true.
Yay. I just ordered 2. I'm pretty excited.
It'll be just like that, except for
Free.
Yeah, right?
Well, yours are technically free too, but you did the order process.
Yes. Okay. What I want to show off is I want to shout out Dan. That's what I decided to do. So I'm going to screen share here. And this is a pull request. Dan Halbert just started working full-time on CircuitPython with us, which is super exciting. This is just one of the pull requests he's done. So I just want to say, Dan, we're happy to have you. And that we're also doing all code reviews and stuff. So no code goes straight to the repo anymore. So we're going to go through the same process as anyone else who contributes, which is really good. It's good to have that availability of anybody can contribute to CircuitPython. And then the other thing I wanted to point it out here was when you create a pull request, which is like you've written some code, you change something, and you want it for everybody to use it, you do a pull request, say like, here, make these changes. What it does is it automatically gets tested, and the Rosie CI stuff is testing it automatically on the boards. I showed that before, but it actually works now where you can see that on this pull request, 3 checks passed. Travis, which is like one in the cloud, it's a great service, you should look it up. But then also Rosie CI, and in particular, my version of it also passed. So we're now validating every pull request and every commit on boards as it comes, which is super exciting too.
Amazing.
So that's one of the things I wanted to get done for 2.0. So expect to see either a beta or a release candidate by the end of the week on that.
Yeah, and at Adafruit, we do Hug Reports. So Hug Reports for everyone involved with this CircuitPython project. All boards now have a CircuitPython.
Yes.
Yeah.
Yeah.
That's what you told me.
We have released every M0 board we were planning to for a bit.
Yeah, every
for a little
board.
bit.
Yeah, so we
have a wide range now of
Metro,
every shape.
Feather,
Yeah.
Trinket, Gemma, Circuit Playground.
Yeah.
So we're here. Collect them all.
So you have so many options. You can run on a Trinket size board, on a Metro size board, on a Circuit Playground shape board. Every kind of board can run CircuitPython.
So yay.
So we have now equivalents for all of our AVR boards, pretty much.
Mm-hmm.
All shapes and sizes now featuring CircuitPython.
Huzzah.
Yeah, and the Trinket ships with CircuitPython just like the Gemma does, which is exciting.
And then we're going to go back and we're going to redo the Feather and the Metro and the Circuit Playground. We wanted to get the hardware out first, but now 1.0 is done, so we can kind of go back and redo those.
Yep.
Very
super
exciting.
Okay, so good work, everyone. Okay.
Thank you.
Next up, let's go to Matt.
Hey, Matt.
Hey, Matt, how's it going?
Hey guys, PiGlass is 3 weeks old today, and I got the microphone working. Verizon gave me a jetpack, so now it's mobile. I replaced.
Just walk in and say, "Give me a jetpack."
No, I have friends that work there.
Yeah, I mean, you kind of look like somebody who needs a
because
jetpack.
I think that just might work too.
Yeah, so I replaced the keyboard with my phone. I SSH in on my phone. You can do YouTube audio streaming with MPS YouTube, and using the Raspberry Cast app on your phone, you can actually stream YouTube to the PiGlass.
Intense.
So I'm going to show you guys what the camera sees right now with a little screen share.
You're gonna screen share to your eye. That's so cool.
That's cool. Oh, it's nice out.
Wow.
Yeah, like boats and stuff.
So that's all we got so far. The voice commands aren't done yet, but they'll be done in a week or two.
Intense.
Matt, this is an amazing project.
Yeah, this is cool.
Thank you for showing this each week. You get a show and tell sticker, but if you want some Adafruit gear, we can send you some too. Whatever.
All right, cool.
Yeah, outstanding. That was so neat. And then the live demo worked.
Yeah,
Woo.
good work. YouTube streaming in and out. Okay, I gotta make notes here.
Okay.
It's intense.
Yeah, it live streams to YouTube too.
Yeah.
Everything should.
You feel now you want one of those.
Yeah.
Yeah. Okay.
I want to wear a portable Wirecast.
You do.
Yeah. Okay.
You do.
I do. No, it's
nothing
true.
shameful about
It's
that.
true. I do. Okay.
You're a man. He wants you that.
Next up, Orlando.
Hey, we can't hear you.
Again.
But I can.
A couple weeks ago, I shared off what I call the LiPo battery breadboard power supply. I
Yeah.
have like really bad naming conventions, unfortunately. So that's kind of what I'm going with. I have a lot to share, but I'll just stick with this one for this week and come back later. So it's basically an easy way to integrate your LiPo battery projects to the breadboard. Just because the JST connector doesn't really fit well to the breadboard because it's 2 millimeter as opposed to 2.5 millimeter. And it kind of has some kind of neat little functions on here too. I know you guys have some breadboard power supplies, so it's inspired by that. So this thing has a little switch. It turns the power on and off. So you can leave everything plugged in without having to turn it off, without having to plug the battery out, which is kind of handy because these are actually kind of snug, really, unless you get like the exact, the right ones with the right fit. And also this one features a battery charger as well. The MCP 73831 IC, whatever that is, that's a pretty popular LiPo charger IC. And so then you have a third light over here that indicates the battery is charging. So switch over to USB power, charge the battery, and and you also have a 3.3 volt regulator. So you could mark, this little jumper here. You can either go with a regulated voltage of 3.3 or the raw voltage. So whatever the battery voltage is at that point versus the 5 volts in the USB. So it's actually ended up being pretty handy. I kind of use it all the time. I took a ton of them at work. So it's actually been kind of fun. So it turned out nicely.
Nice.
All right, outstanding. Email support@adafruit.com. We'll send you a sticker or whatever else you want.
I think. Do you have a calendar with the oscilloscopes on it? Because if so, that's really cool. It looks like.
Oh yeah. This is from Tectronics, I think it is.
They have an oscilloscope there.
Yeah, they were like, "Oh, what do you get on the engineer's bench?"
Yeah.
And so basically,
That's a good calendar.
That's pretty sweet.
We get DigiKey send us every year. We get like one of the big wall ones that you can write on.
That's good. These are nice photographer. Like
Yeah.
it's nice photography there.
it's really nice. It's cool to see all the Arduino and Raspberry Pi stuff on engineers' desks.
Yeah. Oh, what is that?
In August, what is the electronic item in August?
Switch. So, not quite exactly sure what some of these are, but they're different.
Gotcha. So it's a collage of things.
There's an Arduino, Raspberry Pi.
And then what's September? What's the photo from September?
This person's desk is a little bit more barren. It has a lot more wires and
Oh,
stuff.
okay. So it's a that's cool. It's a neat idea.
Whatever's on their desk.
Ah, neat idea. That would be cool, like a calendar of workbenches or a calendar of EE benches.
That looks
All
a
right.
lot like my bench.
Yeah.
All right, sweet.
Okay, very cool. All right, next up, Roberto.
Hey guys, how y'all doing?
Good.
Yeah.
All right, cool. I hope y'all can hear me well. Today I wanted to show some OpenSCAD stuff that I've been working on. That's based on that one project to make a keyboard out of a trinket, and I'm using the 1009 buttons y'all have in the shop to start with, and it's an enclosure that is written in OpenSCAD. Iteration. I've gone over several iterations, and I had some not so good experience trying to print vertically. Horizontally. So I flipped it on its side and it had better results. And today I was putting it together. It has two pieces, one to like attach the buttons to, and then a little bit of a mounting area for the trinket. As I was putting it together, I wanted to get digital pins 1 and 2 working, and for some reason, digital pins on the trinket 3, 4, and 1 didn't want to work. They were always running as low, so I got to troubleshoot that. But another thing that I wanted to show is on screen, so just give me a moment to share that. Okay, so those are the buttons I'm using. And I'm also implementing a testing framework using JUnits that run through all of the OpenSCAD files I have, and using the executable to create the image so that I can compare them to what I'm expecting to what the proposed baseline will be. And I've mentioned this before, but now instead of running it from the command line, I have more visual feedback. Can y'all see my screen?
Yeah.
Okay, cool. So, I'm running these jobs on commit. It gives me a JUnit report. Built in, it's telling me at the top level I have this many errors, which is not good, but I just started this, so I really didn't know like the count or in which directory I was getting these errors. So this tool is really helping me out to eliminate any new, to detect and eliminate any new bugs that I may have introduced. And so what I mean by the top level is like all these top level directories is the tally over here. So that's really helping out. So I'm familiar with Travis too, so maybe if I wanted it to be online, I could look into that. But for right now, it's just running at my house. And the source code is available on, for the source code for the trinket is available on GitHub, as well as the actual modeling software I just showed. I have some documentation online. I'm documenting as I go. Let me see, there was something on here. Okay, not that. Oh yeah, so there's what the model looks like in OpenSCAD for the top. And then over here I have the actual enclosure, the base of the enclosure. And I think that's all I had to show.
Okay, right.
But yeah.
Email support at Adafruit, and you get an SC on a show and tell sticker, and tell them that you're also getting a Trinket M0. Congratulations.
Yeah, so you can upgrade your project.
Yeah. All right. What's up? Adam. Hello, Adam. Welcome back. How are you doing?
Really good. Had a pretty fun couple of weeks. Just got back from the eclipse, so still a little bit tired from that, but really cool seeing that. And I hope to actually have the microscope online to show some really cool stuff under it today, namely a sci-fi chip that was very, very kindly sent to me.
Yes.
Super, super excited to put this under the microscope, so thank you very much for this.
You think the only chip that they'll be okay with is open source. So they're like actually okay with it. Most companies would be like, oh my God, we're freaking out. But they're like, no, this is totally cool.
No, so that's going to be really cool. And then I also got a couple other things from you guys. I'll just show a couple of them. I got a barometric pressure sensor, temperature sensor, alcohol sensor, some conductive like zip or Velcro, some fabric, all sorts of cool stuff that would just look really cool under the electron microscope. And because these are all MEMS devices that have kind of an open case, they get that because they have to sense the air somehow. They're really easy to decap for me. So they should look pretty cool under the electron microscope. And as far as the electron microscope's doing, let's just say less than well. I'll show you a photo of what it's looking like right now.
It's such a positive way to
Yeah, so I just finished rebuilding the high voltage power supply. This is a Kharkov Walton bridge multiplier, new ceramic caps, new diodes. And when I took it apart, I found the problem child. I had a capacitor that had just started to fail. So the electron microscope was still working when I shut it down. So surprisingly, I still was passing voltage to this thing. But this was definitely the source of my current, and definitely why I was having problems with it earlier. So I also did work on the high voltage tank some. The O-ring failed, and this oil is like the nastiest stuff in the world to work with. It just gets on everything. So I had to figure out how to fix that. So I kind of just sliced the O-ring open, glued it back together with some Loctite 515, called it a day, and then tried to power the SEM up. So I had the SEM running for about 5 minutes a day before a little pop, and everything stopped. And what the little pop was the filament in the electron gun going out. So these electron microscopes has to use a tungsten filament that boils off electrons. And in this case, you can see the filament just kind of melted right there, and that was that. So as I was changing it, I was just about ready to put it back together, and then I noticed some really strange contamination in here. Like I have a crystalline growth structure right here, which is not great. So I don't know why that's there. I got to figure out what that is. I'm going to put it under the electron microscope at some point. But in the meantime,
it's like the plot to like 7 different sci-fi movies. Be careful.
Yes, this is. I'll wear gloves the entire time, and I'll keep it under a fume hood, and it'll probably be safe. Unless it becomes sentient. But anyway, so I had to replace that. And replacing this is way harder than I thought it was. You have to like perfectly align the filament inside of the anode cage. And we're talking like within like thousandth of an inch. And you have to do this visually with set screws. So that took a really long time. I didn't think it would take that long, but I got it mounted back up at the microscope, powered the SEM back on, and I got this. This is kind of the same image I had earlier, or before the filament burnt out, but it's indicating that something's really weird going on at the microscope. And then I also noticed that I have a lot of voltage sag, which is not great because it means I have a lot of excess current draw, which leads me to believe that somewhere I've had another transistor that's failed, which doesn't surprise me. All these transistors are very old and very prone to failure. They don't have very good thermal management on them, so they all run a little bit hotter than the spec says they should. So I'm going to have to trace that down. That's not going to be necessarily easy because there's literally hundreds of them in the SEM. But all in all, it's moving ahead. I did hope to have the chip under the microscope today, but microscope had other plans.
Yeah, it's fine.
This thing is totally like it's like a pet.
What's cool is when you work on a project for a really long time, when stuff comes up, it's not a big deal because the entire project takes a long time. Like, what's the difference? A couple days, couple weeks, in the lifespan of the entire project? It's nothing.
Okay.
So, okay, we're still trying to get more unique, interesting chips to send you.
Oh, totally.
So stay tuned. We're also talking to large chip companies, and we want to do a video series called Chip Tunes, where we play cool music from musicians, and we show chips under microscopes.
Oh, there we have a microscope here. You have a microscope. We're good to go.
Yay!
See, so if you've ever seen really boring videos when a company releases a chip, it's usually a rendering, and it's like the 575. So we want to change that. So we'll see. We're gonna do it anyways, but
totally.
Yeah. All right.
Fun
Okay. Well,
times.
thank you, everybody.
Okay, thanks, everybody.
Thank you, Tony. Thank you, Scott. Thank you, Orlando. Thank you, Roberto. Thank you, Pedro. Thank you, Matt. Thank you, John. And thank you, Adam. We're here every single week, 7:30 p.m. Eastern Time. Show and tell. Show and share your projects here. And
to us,
you can hang out at adafruit.it/discord or discord.gg/adafruit, and you can show your projects all week.
Yay!
All hours.
Yeah.
24/7. People do now. We have a show and tell channel.
And we're going to be doing stuff on Saturday.
Some folks just want to show a picture and type. We got that. They want to just go into the voice chat and say, "Let me tell you about it." That's fine.
Fine.
Yeah. Okay.
Fine.
Bye, everybody.
See you soon.
Yeah, ask an engineer in like 5 minutes.
5 minutes.
Okay. Yeah. Forgot.
Yeah,
we're also doing another show.
We're doing another show. We have to set up for the show.
Yeah, we're gonna do.
We'll do that now.
A show.
Yes.
Okay.